Hi, in this lecture I will be focusing on the basic principles of signal processing and basic principles of optical signal processing, basic principles of analog signal processing, and some comparison with the digital signal processing. So we can start from the introduction. Firstly, signal processing, what is it? It is a kind of terminology which indicates the processing of the signal. Signal can be processed in many ways, like it can be filtered to remove some noise, it can be twisted and tilted, modulated, demodulated, and many different kinds of ways by which a signal can be manipulated, and this can be described by the terminology signal processing. What is signal? It is any information is represented in the form of signal, and the sender is sending the information, the receiver is receiving the information. So these can be two devices, one for sending signal and other for receiving signal. We have different kinds of signals which can be one dimensional, which can be two dimensional, like we have any kind of signal which has only one independent variable like time on the x-axis, then that kind of signal is said as one dimensional, and any signal which has two independent variables like in the image signal, then that is being said as a two-dimensional signal. And signal can be a continuous signal as well as it can be a discrete signal. Continuous signal contains infinite number of points. It is basically described or demonstrated with reference to infinite number of time points, while the discrete signal is represented only in some discrete intervals of time, not like infinite case in the continuous time signal. Discrete signal is defined at some finite intervals of time. Signal can be representing some electrical energy, optical energy, any kind of energy which can be in a sinusoidal or non-sinusoidal form. And then we come to noise, which is not representing any information. So any signal which is not representing an information is said as a noise. We have an example of classroom in which two people are discussing something with each other. One person is sending some information to another person, which is a signal to the other person with which he is talking. While there are many other people which are also present in the classroom, but for them, the signal is not a signal, it is a noise for them. So, any signal for two people communicating with each other is a signal for them, but for the rest of the class, it is just a kind of noise because they are not concerned with that kind of information. We have some practical examples of signal transmission, like we have a transmitter which is sending information to the receiver wirelessly. Then when the transmitter is sending the signal, some kind of noise is added by the internal circuitry of the transmitter and also from the environment from which it is sending that signal to the receiver. And when the signal reaches the receiver, it is not a pure signal, but it is also containing some noise, and it is a kind of composite signal which is containing a signal plus noise. So on the side of the receiver, it is necessary to remove that noise and we have to do some signal processing over there on the side of the receiver. So this is a kind of motivation of the signal processing. Now, what is analog signal processing? We have three kinds of signal processing, one of which is analog signal processing. Other two are optical signal processing and digital signal processing. Analog signal processing is removing the noise from the signal, and it is using some active or passive electrical and electronic elements. And we have uh, we have to go back to the 1960 scenario when we have satellite which is sent in the environment, and it is taking a lot amount of pictures of the earth, and those pictures when received at the ground station are having too much noise, too much blur image. So there was too much noise in those pictures. So which is needed to be removed because the data of the picture is a too much kind of gigantic data and needed some fast processing uh, tools which can be doing this kind of filtration. So analog signal processing was not as much fast, and due to that reason we focused on these two, which were optical signal processing and the digital signal processing. Optical signal processing is performing its operation in the parallel fashion, while the DSP is performing in a serial manner. We will be doing some kind of more analysis on these two after we will be discussing the principles of analog signal processing. This is a block diagram of analog signal processing in which we have any kind of signal which is which is received by the receiver. This is basically a kind of receiver because signal processing is mostly performed on the side of the receiver. So this block diagram is representing a complete receiver from which it is transmitter is sending the signal in the environment, and this receiver is receiving that signal. It is doing its amplification, and that signal is a combination of the signal plus noise, and this filter will be removing the noise, and then the signal in pure form will be amplified and then used for later purposes. So this kind of circuit will be involving a filter which is containing the active or passive electronic or electrical elements. So this is an example of analog signal processing. We can have different kinds of filters, like we can have low pass filter, the high pass filter, the band pass filter, and the band reject filter. High pass filter is allowing the frequencies of high uh, amplitude, and low pass filter is allowing low frequencies, and band pass filter is allowing some bands of frequencies to move across it and blocking the rest, and the band reject filter will be rejecting some bands of the frequencies and passing other frequencies through it. So we have different kinds of ways by which we can design these filters in the uh, analog regime. So this is an example of an analog filter, which is a low pass analog filter and is made with RC elements, which are passive elements. We have also ways of operational amplifier active elements to design a filter. In this example, we have a low pass filter which is made from the RC element. We can make a filter with RL element as well and LC element as well, and we can now have to analyze this filter. What we have to do is we have to calculate the transfer function of this low pass RC filter by getting output voltage and input voltage and doing their uh, ratio calculation V naught over Vi to get the transfer function of this filter to see its response in the Bode's plot. So we have, after doing the derivations, we have analyzed the input voltage, the output voltage, and then we have done the ratio calculation, and after that we will be having this kind of expression, and this expression is having the cutoff frequency. That cutoff frequency is basically the upper cutoff frequency within which the frequencies will be passed through the filter and the above frequencies will be blocked by the filter. So this transfer function, when plotted on the y-axis and the x-axis, is indicating the normalized frequencies, which is W divided by WC, then we can see that after WC the frequencies are blocked by the filter, and before that the frequencies are passed by the filter, and there is zero kind of attenuation. And after the once the frequency WC reaches WC, then after that there is a kind of attenuation which is happening in this manner at minus 20 dB per 10 values. So this is a Bode's plot, and it is telling us the response of the filter, which is a low pass filter, analog filter. Now we will be looking at the principles of optical signal processing, which is a technique of processing signals at the optical frequency. The optical frequencies is within this range from 100 microns to 0.1 microns, and which is involving the infrared frequency, the visible frequency, and the ultraviolet frequencies. And the analog signal processing and the digital signal processing are operating normally being done in the radio frequency, the microwave frequency, and the millimeter wave frequencies. And they can also be used for the optical frequencies, but uh, in DSP, when DSP is used for the optical signal processing at the optical frequency, then it will be having some delay, and analog signal processing will be having a very complex circuit, because higher the frequency goes, the more complex is the electronics. So that's why we have optical uh, signal processor for that purpose. How optical signal processor works is the diagram over here, which is telling the basic principles of a optical signal processor, in which we have a laser light which is putting uh, which is emitting laser, and we have an expander lens which is broadening the beam of the laser, and it is impacted on a transparency material which is a photographic material. And once the photographic material analyzes any lines or any dots in the signal, then it has to be filtered, and then this laser light, after it is detected that there needs some filtration in it, a kind of lens which is narrowing the broad beam of laser, and to put it on the filter material, which is a very narrow small hole through which only the signal will pass and the noise will be subtracted from here, and then that beam is broadened and being put on the screen, and the signal is processed. This is how an optical signal processor works normally. Now we have to do some comparison between the optical signal processor and the DSP. The optical signal processing is a parallel technique which is very fast, and the DSP is a serial processing technique which is a bit slower than the optical signal processing, but it is also fast. And secondly, the optical signal processing is done at the speed of light, while the DSP is being done at microwave millimeter wave frequencies or the radio frequencies, which is a bit uh, lower frequencies than the optical light frequencies. But there are some disadvantages of the optical signal processing is that it involves a photographic material which is used for optical signal processing, and it is necessary, and it is a very kind of difficult process to uh, create an environment of optical signal processor uh, due to that chemical process of the photographic material, but this process is not involved in the DSP, so that is a disadvantage for the OSP but an advantage for the DSP. Secondly, there is a kind of another disadvantage in the DSP is that an appropriate filter for filtering is not available, and it is a kind of difficult process to create an environment of that filter, but the designing of the filter for the ASP and the DSP are easy, so that's why DSP is preferred over OSP. Thank you very much.